Hi, good morning, good afternoon, depending on where you are in the world. My name is Paul Roberts. I'm a principal solutions architect here at AWS. And today, my friend Nima and I would like to talk to you about automating your infrastructure deployments on AWS. And here at AWS, we're actually seeing an evolution of infrastructure as code across many of our customers and kind of the tooling that they're using. So the purpose of this presentation is kind of to dive into some of the things that we're seeing and how you can even leverage these technologies with Spinnaker for your own deployments. So let's dive right in. So the first thing I want to discuss is going back to automation level 0. And this is where, if you want to go back to kind of the early 2000s where we were still writing a lot of Perl, a lot of shell scripts, you can kind of see this picture here where, the data centers, it kind of looks like that the computers, the back of the computers, they just kind of like threw up on themselves. It was really difficult back then. And, if you wrote an awesome shell or Perl script, like you were really proud of yourself. I know I certainly did this back when I worked at Sun Microsystems. But automation was kind of difficult. You had to write everything, with Perl or shell. And it was just really difficult to get through this. So automation level 0 was very manual, very cumbersome. There wasn't a lot of tooling. Maybe you had your own subroutines that you had written that you could reuse over and over. Maybe you even got as sophisticated as using CPAN back in the day. But there had to be a better way. And so, what was that? So moving forward, let's look at automation level 1. This is where, your first infrastructure as code begins. And this is probably taking you to the time of 2007, around then when Chef and Puppet really started getting started. And then later in 2010 and beyond, you started seeing things like Ansible and Salt. But really, this is where we were taking an imperative model, and instead of writing things with shell or Perl, we had to learn a new domain-specific language, a new DSL. And here we had to tell or use these languages specifically to say exactly what we wanted to do. Now, the benefit here is that other people were also writing their own code. And so now you could share this. You could share these resources, and you could share this abstraction across companies and across infrastructures, if you will. And so this was certainly a step in the right direction. I certainly wish I had this, back when I was at Sun. But there's still a long way to go here, and people are still certainly using these tools, but there still has to be a better way. So now looking at level 2, this is where you have a declarative infrastructure as code base. And this is where you see the introduction of tools like AWS's CloudFormation or even HashiCorp's Terraform. And here, you're actually bringing your infrastructure tooling. This is the code that's written in YAML or in JSON. And this code is going to be now, this declares the end state of what you're looking to actually accomplish. You don't have to go line by line saying exactly what you want to have happen in your infrastructure. So it was much easier than using other existing tools. So even with this, you can see here, this is just a YAML block of actually orchestrating some AWS VPCs. But as I mentioned, you have to still set a desired end state through JSON or YAML. And I don't know about you, but I personally don't really enjoy reading or writing JSON. And then even with YAML, it's still a markup language. This isn't a programming language that I've been using, whether it's Puppet or whether it's Python or JavaScript or TypeScript. So I still have to learn a specific DSL. It wasn't a totally new programming language. It is YAML or JSON, but it's still something that I had to become familiar with. But one of the major benefits here is that now you have reusable components, and you can keep this in your Git repo, and you can continue to use these. A lot of customers of ours, they consider these to be their recipes, their special recipes. Additionally, even within Spinnaker, Spinnaker today supports CloudFormation and Terraform. And as you're going through your Spinnaker pipelines, you could certainly roll back if you need to. So this was a huge step up versus writing custom tooling or custom scripting that you had to have in the past. But there's still a better way, and let's take a look. So now moving towards infrastructure as software, automation level 3. And this to me this is the evolution of infrastructure as code. This is to really where we wanted to be going for the past 20 years. And I think we're starting to really get there. So now a developer, he or she could be writing their code in JavaScript. And we're seeing two major patterns here at AWS, and this is with the AWS Cloud Development Kit, or CDK. And we're also seeing more adoption of Pulumi, which is another infrastructure as software platform. But these two tools accomplish the same type of outcome here, where you can actually write your code as your software of choice. Here I selected JavaScript or TypeScript, but it could easily be Python or Java or some other language. And so the benefit of this is that now you're actually writing in a familiar programming language. So you don't have to go out and learn a new domain-specific language. You don't have to write in something like YAML or JSON. This is much simpler. And so for all the developers out there that have been writing code in their language of choice, now they don't have to think about, hey, I'm going to write something for AWS, or I'm going to write something for one of my on-prem environments, and it has their own specific languages. It is specifically your programming language here of choice. So within this, these toolings, they have their higher level abstractions, which they call constructs or components. And these constructs or components are basically classes that are being built. And here in this example, you can see that someone is creating a new service, and this new service is going to have a VPC. This new service is going to have an ECS cluster and also an application load balancer. So every time they want to reuse this construct or this component, they're going to call my service. And this is still a declarative way to accomplish what you're looking to do, because you're not saying, I need this specific logic to do something exactly as I'm describing. So with both Pulumi and within CDK, there's a lot of people that are writing their own resources or their own components or constructs that you can reuse in your tools. The other thing I'd like to highlight here with these frameworks is that it isn't specific to your infrastructure. This can also be used to automate your applications. So we're actually even seeing customers leverage tooling like this to automate their Kubernetes deployments, to actually deploy their applications with these tools. So here's another example, and we kind of touched on this a little bit about how CDK and what Pulumi is doing here. But again, you have a new VPC that needs to be created. And here in this one line of code, I'm saying, give me a new VPC, create a new stack, and I want it to be in 2 availability zones. And when you do this, you could use a single command line input, CDK deploy or Pulumi up. Then what you see here that's being referenced is that one line of code actually gets interpreted where it says, hey, you're going to need an internet gateway that needs to be created. You're going to need a NAT gateway that needs to be created in both availability zones. And if I said max AZs 3, it put another NAT gateway in the other availability zone. So this automatically gets taken care of for you. However, if you want to customize this, you can create your own construct or your own component that represents what a VPC is. So you could call it Paul's VPC. And then every time you call Paul's VPC, it would stamp out exactly what I'm looking for. Again, using the programming language of your choice. So again, here, talking about this idea of creating this new VPC, it's really hard to see this, but here, if I were to do this with CloudFormation, this could be up to like 270 lines of code. And I don't know about you, but personally, I don't want to be writing 270 lines of code in JSON or YAML. So a single line here is much simpler, and we're seeing a lot of adoption with these new tools. And we're actually dogfooding this quite a bit here at AWS. I myself and team will be publishing a blog representing some of the things that we're working on here in the next few weeks. So lastly, I want to hit on a couple things. So starting at the bottom, at the beginning, back again in the early 2000s, this is where it was a very manual process. We had our wikis, we had some playbooks. I think we can all remember when our managers and our leaders back then said, hey, do you have a run book? And if you didn't have a run book, you had to go ask Bob or ask Susan, like maybe she knows how this works. And that was really tough. And then the next level was, well, can we script some of this? And this is when we started writing a lot of our code, in Shell or Perl. And you said, well, we don't have to go ask Bob or Susan anymore. We can do this and it's all automated. We can go look through the code to figure out what's happening. But then there was the next step where it was a declarative way where let's introduce CloudFormation or Terraform. And the CloudFormation bits, it was great. It was AWS specific and it helps customers onboard to AWS. And then the Terraform side, it supported multiple providers, but I still had to learn a specific DSL and it wasn't ideal. Then moving beyond, I think the developer community said, well, you know what? We don't want to have to learn how to write CloudFormation or Terraform. So let's build some code that can actually generate the code that will go into CloudFormation or Terraform. And so this is like Troposphere or GoFormation that helped you with this, but it was still an intermediate step to where we really wanted to go. And the final step is the abstractions. And this is where AWS CDK, the Cloud Development Kit, CDK8s, which I haven't mentioned yet, and that's kind of on purpose because my friend Nima is going to go into this here in a moment, and Pulumi, which is again another infrastructure, a software programming language that you can leverage. So with these tools, CDK, CDK8s, and Pulumi, this is the future as we see it, and I highly recommend you take a look. And today, Nima is going to walk you through some of the work that we're doing with CDK8s and Spinnaker. So with that said, Nima, take it away.
Okay, thank you very much, Paul. So before we get to the demo and show how CDK8s integrates with the Spinnaker, I want to quickly talk about why the CDK integration with the Spinnaker and with the CDK tooling is actually important and useful. So what CDK allows you to do is that it allows you to define your resources for your infrastructure. So for AWS, for example, you will be able to define your public subnet, private subnet, internet gateway, VPCs, etc., etc. However, if you have your Kubernetes cluster going, and if you have your infrastructure set up with CDK, then when it comes to deploying applications on top of Kubernetes, in the absence of CDK, what you had to do was to go back to the existing tooling to deploy your application to Kubernetes. That basically means to use vanilla YAML documents to specify Kubernetes resources, or to use tooling like Helm and Customize. So what CDK allows you to do, and the likes of CDKs, Pulumi, for example, is that you can define the end-to-end stack for your software application using the language of your choice and use the same runtime or sets of runtimes in order to deploy your application. So with the same Python script or your TypeScript that you set up your infrastructure for AWS, then you can define your Kubernetes cluster, then you can define Kubernetes resources, whether it's services or deployments, and then the entire thing can be checked in, let's say, to your favorite resource control system, Git, and you can pull it down, have it pass to your CI/CD platform, and the platform will take care of it for you. So that disconnect, it actually is removed as a result of buying into the end-to-end framework or runtime for deploying your application. So here, for example, you will see a very simple example of how you can define Kubernetes resources and a service and a deployment in this case to define the software stack that your application requires. And you can combine it with whatever you have for your setup for VPCs or public subnets or internet gateways and pass the entire thing to your CDK runtime and have it take care of it for you. All right, so with that, we can go to the demo and see how CDK's integration with the Spinnaker works. Let's just start with creating a pipeline. We'll call it CDK, and then we go add a new stage for baking a manifest. So baking manifest previously existed for Spinnaker, but before it only supported Helm and Customize. Now we've added CDK support. So once you select CDK, then you choose to define a new artifact. It has to come from a Git repo, obviously. And so I have a Git repo here. For the CDK example, you see it's a Python application. I basically took it from the examples that they have on their website. Let's copy the reference to this Git repo, drop it in here. And also, if you are familiar with CDKs, you know that it supports two different languages, Python and TypeScript. In this case, our repo is written in Python, our code is in Python. So we select Python, and then for the artifact that it produces, that's basically the output YAML document. So let's edit the name and call it CDKs output. And it will be base64 encoded, saving the artifact, saving the stage. Next thing we want to do is that we want to have a deploy manifest stage. Cool. So under deploy manifest, you select your Kubernetes account, and then you choose the artifact that is produced by the CDKs renderer, and that is pretty much it. So you save this new stage, you have your pipeline ready, you go to pipelines, and here I just triggered manually. Let's start manual deployment, run it. You see that it kicks off. The first stage is baking the manifest using CDKs. And once this is done, it proceeds to deploying the manifest. Waiting for this to finish. Cool. So baking the manifest is finished. Now it proceeds to deploying it. You see that it actually creates the objects. If you look at the code here, you see that there are two objects in this file. One is the service and the other one is the Kubernetes deployment. So those are the resources that we expect to be created here. You see that it's actually doing the deployment of the load balancer and the deployment service on Kubernetes. Waiting for this to finish. Here we go. This is finished as well. You see the task status is complete. We have the service and we have the deployment. Let's look at the details. Under the load balancer, you get the new deployed service. This is the one. And you already see the ingress is available for it. If I click on it, the service endpoint isn't available yet. It takes a little bit of time for the population of the service endpoint so that it becomes publicly accessible. But once it's done, you will be able to ping the service. Waiting for this to become available. There you go. So you see that the service is available. And that's the end-to-end deployment using CDKs. All right, now that we've seen the demo, I think we've pretty much covered everything that was intended for the presentation. Thank you very much for joining Paul and myself for this presentation, and I hope you found the information useful. Please feel free to reach out to either Paul or myself if you have any thoughts, any questions, or anything that you would like to discuss when it comes to infrastructure as code. Thank you very much and have a good rest of the day.